Number 7, there's 3 parts. Yay! I know you're excited for that. So we have a picture here. We have a rectangle within a rectangle. So the smaller rectangle I highlighted there in red, and then the best color ever, the larger rectangle, I highlighted the piece that you can see at least in pink. So part A, write an expression to represent the area of the larger rectangle in expanded form. So we need to know how to find the area of a rectangle. Hopefully remember that's length times width. So I'm going to put an L for length and W for width. And it depends on your perception as to what the length and width is. I could say, for instance, for the larger rectangle, the length would be the 6x plus 2, and you might say, no, I say the length is the 6x minus 2. Well, it really doesn't matter because you are multiplying them together, so you're going to get the same answer no matter what order you multiply them in. So, larger rectangle. So I'm going to put an L to represent the larger rectangle. So 6x plus 2, I'm going to say is the length. So I'm doing length times, the width. The width would be 6x minus 2. And it says, right now it's in factored form, it says to write in expanded form. So we're going to have to apply distributive property here to expand this. So distributing a 6x to both terms, 6x times 6x is 36x squared. 6x times negative 2 is negative 12x. After we distribute the 6x to both terms, we're going to distribute the 2 to both terms. So 2 times 6x is 12x. And 2 times negative 4 is, 2 times negative 2 is negative 4. Alright, from our list, looking at the 2 middle terms, hopefully notice that they cancel out. One's a positive and one's a negative, so those are gone. So the final expanded area is 36x squared minus 4. So for part B, we're doing the exact same thing, except it says to write the area of the smaller. So the smaller would be the red rectangle. So I'm going to say the length is x plus 3 and the width is x minus 3. So again, I have to write this in expanded form, so you're just distributing x times x is x squared, x times negative 3 is negative 3x, 3 times x is 3x, and then 3 times negative 3 is negative 9. Again, you're going to get the same thing here because the signs are plus and minus. The x's cancel out, so these are completely gone. So the expanded form would be x squared minus 9. So lastly, part C. Let me read the paper. It says, express the area of the lighter shaded region, which in this case is the pink. So find the area of just the pink and express that in expanded form. Well, if I gave you a pair of scissors and I told you to take this, if I had this on a piece of paper and I said, cut out and just give me back the pink shaded, because that's the area we want, the pink, you would cut out the red rectangle. So you're starting with the entire larger rectangle, so the larger rectangle, and you would cut out the smaller rectangle, the red, in order to get the pink area. So that's all we're going to do. We're going to take the larger area, which is 36x squared minus 4, and we're going to subtract that from, be careful, the smaller area has 2 terms, so you must put it in parentheses, x squared minus 9. So I'm going to have to do a little bit of erasing here to get rid of some of this, so we can subtract. So here's where we're going to do the subtraction. So I have 36x squared minus 4, the larger minus the smaller, x squared minus 9. So what property do we have to apply if we have subtraction of polynomials? We have to apply the distributive property because there's really a negative one there. So it's 36x squared minus 4. Distributing a negative 1 to both terms just changes both signs. So negative 1 times x squared is negative x squared. Negative 1 times negative 9 is positive 9. So from here we're just combining like terms. 36x squared minus 1 would be 35x squared. And then lastly, I've got negative 4 plus 9, so that would be positive 5. So this would represent the area of the pink shaded portion.